my name is Stephen Costa. I'm the Director of Technical Services at Microsol Resources, but I also have a background in civil engineering and worked in the industry for about 7 years before joining Microsol. Mainly with a focus in transportation engineering, but having dabbled in a little bit of everything during my career as an engineer. So as Harry pointed out, the purpose of today's webinar is to go over a number of the products that are within the AEC collection, and really the focusing primarily on the different aspects of the AEC collection that may not be used on a regular basis by users that either are not familiar with what the software does or are not too familiar on how to get started. So as I was mentioning, there are a number of products within the AEC collection that are extremely powerful and have a lot to offer in regards to their output, and how they integrate within a project has various uses, which will depend on ultimately what your goal is for that project. But you can also look at it from the perspective of adding a value-added service to what you provide to your clients. So the products that we'll be looking at vary immensely in what their function is within the AEC collection, but primarily we'll start off with Map3D and Infraworks for some GIS data manipulation. Then we'll go into Recap Pro and look a little bit at how to process LiDAR information to bring into other authoring applications like Civil 3D or Revit or even Infraworks. Then we'll touch upon Format Pro, which is a great conceptualization tool, very similar to SketchUp. In fact, pretty much all the same tools you'd find in SketchUp, you'd find in Format Pro, with the added bonus of being able to integrate easily with several of the other applications like Revit and Dynamo. And then we have Dynamo Studio, which is a great application for doing some computational design. Vehicle tracking, which is great for doing swept path analysis and parking layout. And last but not least, if we have time, I know we're getting a little bit pushback with the delay in showing the screen, but we'll touch on 3ds Max Interactive just to show you very quick how to bring in information from an outside source into 3ds Max Interactive from a product, let's say, like Infraworks. So Map3D, right? Built on top of AutoCAD, has all the same AutoCAD functionality, but it's excellent at manipulating GIS information. So a geospatial information system, what is it? Well, it's used to capture, store, manipulate, and analyze spatial or geographic data. So if you use Google Maps, you're using geospatial data on a daily basis. The kind of information that's available is pretty simplistic. It's all 2D, points, lines, polygons. And you also have the ability to bring in raster images. So think of something like an aerial photograph. Now, there's a wealth of information online. I provided 2 of the links below, and I'll be providing them, we'll email this out as well, for being able to access a lot of this information online. So what we'll do to get started is just simulate what you'd see if you were interacting with some GIS data. So I'm going to go ahead and bring up Civil 3D, and I'm also going to bring up a couple of those websites that I mentioned earlier. NYC Data, NYC Open Data has several repositories where you can go through and search pretty much anything you want. So if you were looking for elevation data in New York City, you'd find a ton of GIS information readily available, all free, all for general use. And if you're not in the New York City area, definitely search your government sites, as they will have a lot of good information there as well. If you're having particular difficulties finding project information for a location, let me know. Obviously, some locations on the planet are going to have a little bit more information than others, depending on how often they're frequented or how easily they're accessible. But to get started, what I'll do is I'll just launch into Civil 3D, start with a nice empty drawing. And what I'm going to do is I'm going to bring in some GIS information. So suppose I wanted to work on a project in New York City. I'm going to bring in the zip code information for New York City. And by just doing a simple drag and drop, what I can do is see various shapes associated with New York City zip code areas. So as you can see here, I have a map of all of New York City. And if I'm really interested in viewing this from a GIS perspective, I can switch my Civil 3D workspace to planning and analysis and see that information was brought in. Now, I can bring in one piece of information at a time. I can bring several pieces of information all in at once, and I can query all that information so that if, for instance, I only was curious about a particular area, so I'm going to go ahead and enter in a zip code and enter in a value. So for Brooklyn Heights, I'll go ahead and I'll just enter in that zip code. You'll see that it filters out only that information. All right. Now, if I wanted to bring in additional data, I could just do a very simple drag and drop. So I'm going to go ahead and bring in sidewalks, some roadways, a parking lot, a park, some water, some contours, and some buildings. And I'm going to drag those in at once, and Civil 3D is going to process that information. And it'll take a couple of seconds, but ultimately all the various data types that I've brought in will appear on the screen. And you can see it building slowly but surely, and there we go, right? Not too shabby in terms of performance for literally bringing in all the information for the 5 boroughs. So I'm going to focus in on an area specifically that I'll use throughout the project as part of an area of focus or an area of interest. And one of the things that I wanted to bring up in the PowerPoint slide is why would you use a product like Map 3D or Civil 3D with its GIS functionality? Well, for one, you can connect to various GIS data types for project conceptualization. As you saw me very easily and quickly do, I brought in all this free data. It's at my disposal. I can use it in any which way I want. For very simple presentation graphics, I can style that GIS data for to print out a PDF, to send to a PDF for manipulation in Illustrator, right? A lot of practical use for actually creating presentation type graphics using geospatial information. And lastly, you can also output GIS data for downstream use. And I'll show you those 2 bottom bullets. I'll show you examples of that right now. So if I jump back to Civil 3D, what I can do is start styling this. And I can do that by just double clicking one of the layers. And I'm going to go in here and start manipulating some of the style data and in the order that information appears. So if I want to use that as a white background, I can. I'll jump to buildings. Maybe I'll make the buildings like a dark or light gray, nothing too exciting. And the reason I like doing this in real time is just because it really helps drive home the point of how easy and accessible a lot of this information is. Now, hydrography, let's go ahead and make I know it's a little bit brown and it's the East River, which is probably appropriate. Let's go ahead and make that water blue. And I'm going to go ahead and make all the parks information green. And oops, wrong button. There we go. Style. Let's go ahead and make that green. And we'll make parking lots gray, and we'll wrap up road beds and sidewalks with other shades of gray as well. So let's do something like a dark gray, and we'll do road bed. And at any point, you can go ahead and style and order these in a way that you see fit, right? So I'll go ahead and I'll leave sidewalks as blue for the sake of time. And what you can see is I can drag and drop contours, layers above everything else. I can put buildings all the way at the top so that my contours aren't going through them, right? And as you zoom in, you can see that all that information is easily accessible, easily presentable, all right? What I can also do is generate GIS data. So as an example, if I wanted to specify a project region, right, I can go ahead and draw a shape and use that information to push downstream into Infraworks, which you'll see next. So I'm going to go ahead and just start with a simple polyline. And from somewhere out here, I'm going to go ahead and draw a line through Atlantic Avenue, up Court Street, just past Cadman Plaza, up Clark. And if I pan over a little bit, I'm going to go ahead and just close that shape. And I'm left with a nice simple polygon or a polyline, right? If I drag over my properties window, you'll see that there it is. What I'll do now is I'll use the map export button to go ahead and output this to a location, right? I'll throw it on my desktop for now. And I'm going to call this area of interest. And I'll go ahead and I'll press OK. And stepping through this process, all I'm going to do is specify that that information is a polygon, which is one of the data types that I mentioned earlier. And I'm going to add just a little bit of information if I want to. For instance, I could add the area of that, and all that information would get pushed downstream if I needed it to. I'll go ahead and I'll click OK. And if I were to go browse to my desktop, you'd see that there's my area of interest, there's my shapefile and all the associated files that come along with it. All right. So that little flavor should have gotten you a good taste of what Civil 3D and Map 3D are capable of within that space. So I'll go ahead and I'll move on to the next part, which is a little discussion on Infraworks. Now, as you saw, I was able to bring in that information into Map 3D quite easily. Unfortunately, because of the limitations of the data type, right, GIS information tends to be two-dimensional, right? So points, lines, polygons, and raster images. So what if I want to be able to take that and make it 3D? Well, Infraworks excels in that, and even though it's used primarily as an infrastructure transportation conceptualization application, you can easily take any GIS information that's available and stylize it and view it in 3D. You can also aggregate tons of different data types, whether they're Autodesk products or not, into one central repository. And last but not least, one of the more interesting aspects is being able to bring in all the building information, and I'll touch upon that topic very specifically. So I'm going to go ahead and go into Infraworks. And from what you can see here in my interface, what I want to show you is that in the same way I did my own research and I found GIS information, if you were starting from scratch and you just didn't have quite enough time to do some research online and you wanted to get a quick and dirty 3D model, what you can use inside of Infraworks is the model builder. Now, the model builder allows you to go ahead and designate a space or an area of interest. I can search by location. I can draw some shapes or polygons that would tell me, would show the area of interest that I'm interested in, or I can import in a polygon from a shapefile, right? So what I'm going to go ahead and do is I'm going to go ahead and bring in my shapefile that I just created, and doesn't create any polygons. So I must have done something wrong. In any case, the fun of a live demo is that I believe I already have this located and saved just in case. GIS and project limits. So I had done that before and I must have blitzed through it because I realized I'm pressed for time and forgotten to do something. In any case, the same shape more or less that I sketched out earlier, I brought in, and I can go ahead and bring this information in. So I'm going to go ahead and assign this a name. I'll call this BH2 for Brooklyn Heights 2, and I'm going to go ahead and click Create Model. So Infraworks will let me know that that model is in process. And to save a little bit of time, it doesn't take more than a handful of minutes. What I'm going to do is I'm going to show you what that model would look like. I did this yesterday and brought in a 3D model. And you can see it's brought in information about roads, about aerial photography, about the buildings, and so on and so forth. Now, again, while this may be exactly what you need, others may have want some more of a simplistic rendition of these buildings. The buildings themselves are just polygonal shapes that are extruded to a particular building height. That's part of the GIS data that's available. So what if you wanted something a little bit more realistic in terms of the actual geometry of the building, and something a little bit more simplistic? Think of what like an architectural model, a 3D model might look like. So I've already prepped that. Now, if we hadn't had a little hiccup in the beginning, I would go through and maybe go through step by step. But what I'll do instead is I'll jump to the finished model and just illustrate a couple of things. First is the fact that I brought in this model, and I'm just going to turn on all the surface layers. Again, these are exactly the same of GIS information that I brought in when I did my initial query inside of Civil 3D. All right, so I brought in all that data. The only thing that I've done differently as far as the data source is I've brought in a city GML file. Now, that link that I provided to you just a little bit earlier is available for download. It's all of New York City. I believe that all this data was developed in 2015 at level of detail 1 and 2. Level of detail 2 for some of the more prominent buildings in New York City. But all this information is easily available. Here is the catch, right? The most useful batch of information is a city GML file. And if you were to look, you can actually select city GML from Infraworks. The problem is that there was a licensing change in the way that city GML information was processed. So what you need to do now, and again, I'll provide this information, is download this city GML importer. It's a third-party vendor's application. It's licensed specifically for Autodesk use. And you can convert the city GML files, which I downloaded, and I'll just show you really quickly. And actually, I put that on my E drive, geospatial, New York City, and I have my city GML files, right? So you can see here that there's several hundred megabytes and gigabytes worth of data, one of which I already translated to an IMX format, which is what you're seeing here in Civil 3D. I'm sorry, within Infraworks 360. All right. Now I brought in some additional information as a proof of concept that I'll get rid of because this structure isn't here, but we'll get there in a little bit. Last but not least, you can also add a little bit of visualism, visually pleasing realism by bringing in some tree data, right? So for example, I already have some tree data in here. Let me make sure that I've toggled on that data, right? And what you can see here is I've added what are known as adaptive trees, right? And as I zoom in, they get a little bit more realistic at street level. And as I zoom out, they tend to become lighter. So they're, in terms of resources, they're less heavy. One quick little note that's useful for randomization of elements like this within an Infraworks models, to again add that little depth of realism, is to go through and make sure that you add a little JavaScript to the rotation axis. So along the Z-axis, I can rotate, and I can specify a random number between 0 and 1 and have that multiply against 360 degrees. So that gives me a non-uniform layout of all these trees. Again, just a little touch of things that can make a presentation look a little bit more realistic and less just out of the box. All right. So again, I'll provide the links for that information. But again, in the information you saw in Map 3D, exact same data, only this time only just in 3D. All right. So moving on, recap and recap photo, right? So recap and recap photo are a part of the AC collection. Recap focusing primarily on processing LiDAR information as well as laser scanning, processing, and locating. And there's also now a new feature called Recap Photo. It used to be called Remake, if I'm not mistaken. Autodesk rebranded it, as they tend to do, and now it's a desktop app that plugs into your cloud service. So what's the usefulness of Recap? Well, you can again process any point cloud data information for use in downstream products like Revit, Infraworks, or Civil 3D. You can transform coordinate systems. Now, again, within the infrastructure space, understanding coordinate systems is part of our day in, day out. I do see there are a number of architects in the audience who work for maybe multidisciplinary firms. Understanding coordinate systems is a topic I could easily spend an hour on, but I'll just go to say this. If you know the coordinate system that's part of the data that you're collecting, you can easily transform it in Recap. And I'll go ahead and I'll do that for you so you can get a view of just how easy and seamless that is. I'll process that information for use within Infraworks, and then I'll show you a quick idea of what Recap Photo is capable of. All right. And again, there's a lot of good information online. Interestingly enough, without getting too political, right, I wrote a blog about how to get NOAA, National Oceanographic Administration, LiDAR scans, because they are a government page. Okay, it's working today, but because I was getting some screen captures over the weekend, because of the government shutdown, this page was dead with a government shutdown notice. So nice to know that it's back up and running, and you can download all the LiDAR information I'm about to show you freely from their website. So I'm going to go ahead and launch Recap since I don't have it open at the moment. And I'm going to just show you how easy it is to go through and create a recap project. So from that website that I showed earlier, I'm able to do something that looks like this, right? Here's that same area in New York City, in Brooklyn Heights specifically, as a free point cloud, right? So I can use that for additional visualization, for checking information about project location, and get a better overall view of my project. Oh, well, that's lovely. Let's try relaunching that again. Nothing like a crash and doing a presentation to muddy things up. But what I'll do is I'll relaunch the application, and I'll show you just a location of where I keep my LiDAR data. right? So if I were to go to my geospatial information, you're going to see that I have some LiDAR information, right? An LAS file, which is about 260 megs. That information can't be processed natively within any of the authoring applications. So what you do is you run it through Recap to create an RCP file. So I'm going to go ahead and do that. And I'm going to go ahead and just start a new project. And again, I'll just call this example for webcast. And I'm going to go ahead and just simply drag and drop that information in there, right? So under my geospatial information, New York City, LiDAR, I'm going to just take that LAS file and drop it in there. I'm going to go to advanced, and here's what I was talking about earlier, right? You need to make sure you drop it into the right coordinate system so that you are getting things to line up in the real world. All of New York City, the 5 boroughs and Long Island are part of the New York State Plain Long Island Zone, LI, and then F for foot. So by doing that simple translation, I'm not going to do any decimation to the point cloud. I want all the raw data. I'm going to go ahead and just click on import files, right? And you'll see it process that information here. It happens pretty quickly. And then once that's done, all I need to do is save my project, and then I can bring that into something like Infraworks or Revit or Civil 3D. So once that information is done, I'll go ahead and I'll click launch view, and here I am, right? So I can stylize it in Recap. I can view it. If I want to go ahead and add a little bit of elevation coloring, I can do so. I can do that by changing the different types of spectrums that I want. So if I'm working here, I can control the various, I can control the various, let's see, ramp 1, let's do smooth and a range, and I'll just say maybe from 400, actually, I just noticed one quick thing. Let me make sure my units are set in feet. There we go. That makes a lot more sense now. So if I edit current and I go to range, I can set this to be about 400 feet and maybe 0. And you can see I can style that as need be. I can change the colors. Ultimately, the only real purpose, or the sole purpose of this is to go through and just save it so that I can use it on a project. And again, if I revisit my Civil 3D, I'm sorry, my Infraworks model, you'll see that I've brought in that information already. It's the same point cloud, right? If I were to go to LiDAR data, you can see that the 4920 file here, it's the same one I processed, and it's the same one I brought in. And I'm just going to go ahead and make sure that I enable it to view. And there's that information, right? So again, very easy to see that information in real time in your drawing, and then confirm visually where some information may be incorrect based on the data that you've collected, or within the context of your own project. All right. So let's go back to the PowerPoint and talk a little bit about Format Pro. So why is Format Pro useful? Well, you can do a lot of things that you probably are using SketchUp for now at the moment. So those of you who are using SketchUp, I really suggest taking a look at Format. It has all the same functionality, and it works effectively the same way in terms of drawing and massing. The added benefit that you get is you get, with the Pro version that comes with the AC collection, you get the ability to bring in aerial photography. Again, GIS information. You can perform energy analysis, which Roger showed you last week, and you can also go through and bring in Dynamo scripts. So I'll get to Dynamo after Format, but I'll give you a flavor of all those 3 bullet points right now. So let me go and bring up Format, and of course I don't have it open, so I'm going to go ahead and just launch it. And I'm going to start off with, again, the same exact location, right? Here's my Format interface. I can go ahead and easily select a location. I'll start by just typing in the area code, the zip code. And I'm going to go ahead and say import image, and I'm going to zoom out, and I'm going to go ahead and look at that site where I'd like to try and to drop in some massing, right? So I'm going to go ahead and click finish. And what I'll do is I'll switch over to my top view to make things a little bit easier to see. First thing I want to do is orient my coordinate system so that at least I'm drafting in the same orientation as my roads. And what I'll do now is I'll pop back into 3D, and I'm just going to start drawing, right? And again, the argument here, or not the argument, but the purpose of this is to show you how easy it is to sketch some geometry for, let's say, a building with maybe parking attached to it, right? So I'm going to go ahead and just quickly sketch in a little bit of information. Let's make that 70. We'll go and make that 200 and maybe 110. And the nice thing is, again, because all this geometry recognizes, I can just sort of use my extension snap, and as soon as I close my shape, I have this shape that I can use now to create additional massing, right? So what I'm going to do is I'm going to just go ahead and start drawing some additional interior shapes. One thing about Format that's worthwhile to know is if you're a 3ds Max user, or frankly, a user of any other 3D application, I'd say the biggest learning curve I had learning Format was realizing that Format will clean up a lot of the geometry for you. So if you are working and you're just drawing overlapping shapes like I just did, if you were doing this in 3ds Max, not only with 3ds Max yell at you, but any instructor that you've ever had for 3ds Max would probably yell at you for doing stuff like this. But the nice thing about Format is it cleans up all those shapes for you automatically. So I can start projecting these various geometries, and I can hold down Shift and project these up at 70, and you can see it automatically cleaned up. I can start now editing this a little bit further. So suppose I wanted to, for this parking structure that's going to be located just adjacent to the building. Suppose I want to create a shape like that, and maybe something like this. I'm going to go ahead and drop that floor down maybe 15 feet. Suppose that there is an outdoor pool in this area. What I can do is start cleaning up these shapes. So I can create an offset. You'll see here I'll do a nice offset of maybe 12 feet, and it's a very skinny Olympic-sized swimming pool, but I can drop that down 4 feet. And if I want to draw another line to simulate a break where there might be an elevation change to a lower end of the pool, I can add a -4 there. I can also clean up the shape a bit further by deleting this and adding information such as like a parapet or another extension to the building. So if I were to do that, you can see that I can start just pulling these shapes very easily, very quickly, using simple geometry offsets and push-pull, very similar to what you'd see in SketchUp, right? So I'll do 3, and then I'll add a quick parapet around the entire building. I'll say 1.5. And then I can just press pull this up to actually, let's press pull that up to about 3.5 feet. And again, even though this parapet wraps around the building front, I can easily adjust that just by press pulling and creating a shape like that, right? For the sake of time, I actually had planned to do a little bit more with this. But with our little problem in the beginning, I just want to make sure I cover all the bases. So easy massing, easy to bring in contextual information. I can also import in a bunch of other information that I'd like either as context for the surrounding buildings, or I can link in a Dynamo script. Now, the Dynamo script I've already created, I'm just going to go ahead and drop in, and then we're going to spend a little time talking about that, right? So here's my additional structure. If I wanted to go ahead and look at this, something I created from scratch. It's pretty simplistic. It's a very straightforward parking structure, just the massing shape of it. But I added a bunch of parameters so that you could, for instance, increase the number of floors. You can change the distance between floors. So as soon as that updates, give it a second. All right, so you see I had a number of floors. I can change the level height in between these. And all this is coming from a Dynamo script that I published and have brought into Format. All right. So again, very easy, easily accessible functionality within a product that if you already own, you should be leveraging. And if you don't own, right, you don't own an AC collection, all these different things that I've done, I would expect that at least one one thing maybe has jumped out at you as something that you'd be able to do quite easily, much the way I've just shown. So with that, I'll jump into back to my PowerPoint and talk a little bit about Dynamo. Now, Dynamo is a computational design tool, right? And those of you who have probably heard the term day in, day out, you may be already familiar. What it does is, I'd say it democratizes the ability for non-programmers to use programming to develop a massing study or a project detail. Now, what I'll do is I'm going to step through the parking lot that I created from scratch, and I'm going to show you how to publish that, and then show you how you would also export that information out to other design applications. All right, so I'll go ahead and jump into Dynamo, which again I don't have launched, but I'll go ahead and I'll fire that up, minimize format. And within Dynamo Studio, I'm going to go ahead and just show you the parking lot that I created. Now, it's going to look a lot more complex than it really is, but I broke it out into a couple of different sections, right? The slabs, the ramps, the parapets, and the wall, interior walls, as well as the void. Now, while this may look extremely intimidating, what I can say is this: learning Dynamo certainly takes a little bit of effort, but you'll see that it's really all about understanding geometry and really relationships and lists, right? How to process data and geometry. So you can see here I have a section for the slabs. I have a section that I detailed for the ramps. A lot of this block that I'm highlighting right now is just rinse and repeat to get and iterate through the ramps that I wanted to create in the way that I wanted to create them, and a little bit about parapet information. Right, and I also have all my various inputs that I'll demonstrate in real time for you as well, right? So I can control the parapet height, from 3 to 4. I can change that value to be a maximum of 6 if I'd like, and then I can continue to play around with that and stretch that up as I need or I want. I can again change the number of floors, right? And it's just repeating that geometry over and over and over again as I pan through. You can see that as well. I can change the level height as I showed you earlier in the Dynamo script. I can change the slab width and so on and so forth. The idea behind all this is that you can very quickly iterate through a series of design options, some of which won't be necessarily the best design, but you can use this to drive some of your conversation. There is a product called Project Fractal, which actually helps you summarize all the different iterations and permutations of this. I just won't have time to show it, but jot it down, look it up. It's in beta, and it leverages Dynamo scripting like you've seen here. To show you how easy Dynamo can be, right? Let's just start off with a simple understanding of how to start with Dynamo, and just a quick lesson in geometry and data manipulation, right? So suppose I want to start with a rectangle. Well, there happens to be a node, which is what this is, that allows me to draw a rectangle with a plane, a width, and a length. So I know that, for example, there is an XY plane node available to me. And I know that there are fixed numbers or sliders that allow me to control the width and the length. So for example, oops, wrong node. If I were to come in here and add a slider, and I want to say I want a maximum value of 300 in 5-foot increments, I can call this my width. And then I'm going to go ahead and just copy paste that, and I'll call this my length. All right, I'm going to plug these into the width and length nodes, and you can see I can very easily now type in a value and see that rectangle, right? And as I zoom out, you can see that in place. Well, what happens if I wanted to create multiple versions of these? Well, I can offset the planes. That's easy enough to do. If I look up, there's a node called offset plane, right? And if I were to offset that plane, right, it would go by a nominal value of 1. But suppose I wanted to be able to sequence that information by saying I need a number of different planes. Well, I can create a sequence that allows me to create some additional inputs. So supposing I want to have another integer slider for the number of floors, right? So I'll go ahead and I'll do an integer. Difference between an integer and a number being that a number is going to have decimals, an integer won't be a whole value of 1, 2, 3, so on and so forth, right? So I'll start off with that. That'll be my number of floors. And I'll plug that into that. And then I'm going to go ahead and just create another node for, actually this time I'm going to go ahead and use a number rather than a integer. And I'm going to go ahead and say my floor heights can just vary in steps of 0.1 from 10 to 15, right? Then I'll plug that into step. What I'll do now is I will add that as a sequence to the distribution. I'm sorry, I will add that to number of floors. I want to do to, yeah, let's do that and that to planes, right? Actually, you know what? What did I mess up here? That's what happens when you're trying to go through quick. Bear with me. I'll just show you the inputs. I realize it's about 11:50 or 11:45, and I have a few more things to cover. So I'll step through it, right? Here's my sequence for plane offsets. I stepped it out through the various distances, and I offset those various planes, XY planes, by those increments, right? Starting at 0, going from a number between 0 and or 1 and 10, and then by an amount of 10 to 15, all right? Then what I did was I offset those planes again, right? So that I have a double set of planes. And let me actually turn off the preview for these and turn on the previews for these two guys so you can see it. And you can see that it's really made up of one set of planes and then offsetting those additional planes by the slab thickness, right? Again, and I did in a value between 1 and 2. And then last but not least, it's about combining those two lists and creating a solid loft in between them, right? So not very difficult, but it just takes a little bit of time to familiarize yourself with the nodes that are available, and then really it helps you understand how to put together a project from scratch. Again, it lets you also iterate through several design options based on these parameter inputs. When I do have a finished product that I'd like to share, I can use the publish. Let me launch that. I can use the send to web, and I can publish that link to my workspace. And in my Dynamo workspace, I have this custom parking structure that has a unique link, which is this. Here, I'll do another example for webinar. And I'll publish that. And what it'll do is it'll create a link, which I can copy and then form it. If I go to my Dynamo plugin, I can add that link so that I have an additional Dynamo script, right? And you can iterate through those quite quickly and quite easily. So with that, let's go back to our PowerPoint and talk a little bit about vehicle tracking. Now, what's vehicle tracking? Well, vehicle tracking allows you for two main functions, which I find extremely useful. First is swept path analysis, to allow you to understand how a vehicle may move through your site. You can animate that in AutoCAD or Civil 3D or any AutoCAD-based product. And you can also use the vehicle tracking tool to quickly lay out dynamic parking, right? So what are two examples of that? Well, I'm going to go ahead and find Civil 3D. And I'm going to go ahead and open up a couple of just sample drawings just to make things a little bit easier to get through within our time limit. So what you can see here is just a simple AutoCAD sketch of a parking layout for a strip mall, right? So if I wanted to understand a little bit better how a vehicle might access this site, in particular, let's say that there was a delivery truck that needed to access the back of this warehouse, how would I go about doing that? Well, in vehicle tracking, which is a product of your AEC collection, you will have that sitting within Civil 3D or AutoCAD, depending on which product you use. In it of itself, it isn't the product, so you can't launch the quote-unquote vehicle tracking product. You'd be launching this inside of Civil 3D or AutoCAD. And within that ribbon, you'll see that there's two sections, one for swept paths, which is your basically moving a vehicle through your site, and your parking. There's also a whole section about roundabouts, which I'm going to leave out just Because there's not enough time during this presentation, but it's also not as popular as it is in Europe, where roundabouts make up a lot more part of a transportation design. Not to say that it doesn't happen here in the States, but aside from Columbus Circle, I can't think of too many traffic circles inside of New York City. That being said, I'm going to go ahead and just launch into vehicle tracking. And you can see here I can launch by clicking the auto drive. And it allows me to select any number of vehicles, right? I can do a search by region. I can do a search by standards. I can do a search by just typing in the type of vehicle that I'd like, right? Everything from cars to airplanes, right? So you can see an airplane. If I go down to something a little bit more useful for this presentation, you see here that for the statewide US design vehicles based on AASHTO standards, if I go down to 2011 US customary units, right? Here are the vehicles that you'd be using the most, as they actually are relevant or related to a standard used within the United States. So the WB40 is your typical interstate semi-trailer, and that's what we're going to use for this example. All right, so I'm going to go ahead and select that, and you can see information about the various parts of that. You can create your own vehicles. There's a number of additional vehicles you can gain via your subscription. So just know that all that information exists. But to give you a quick flavor, I'm going to go ahead and just start with this vehicle. I'm going to just accept all the default standards, and I'm going to go ahead and place that vehicle so that it's facing in the direction of traffic. Right. Once I've done so, I can start creating and laying out this vehicle. Right. So if I were to try to make a quick turn, you can see here that I'd be running over the curb, running over those trees. So what I'll try to do is swing out a bit and then swing over into the other lane. And by no means is this me being a good driver. This is me just showing you how the tools would work, right? So as I go through, you can see here, I can plot this in any which shape or form. If I want to align this to a particular element within my drawing, I can do so by picking alignment, right? It helps me stabilize my drafting. And then I can go through and do that again to pick, say, something like that there, right? So I know that, for example, my vehicle can make all these turns and pull into its parking spot. At any point, this is a dynamic object. So you can control things like inserting a target point. You can control where the vehicle has turned. You can angle the control of the vehicle start path and so on and so forth. So if I were trying to manipulate this information, I could just simply select one of the grips. I can also scroll back through and get rid of particular targets that I don't want to, like the last target and so on and so forth. And if I need to drop in a quick template of what that vehicle is at a particular location, I can go ahead and do that by placing the outline along the specific path, right? So you can see here I can drop in the vehicle there and maybe another vehicle there and so on and so forth, right? So just a very quick demo of the vehicle tracking swept path analysis. Now to give you a quick demonstration of the parking layout tools. And as an intern and certainly as an engineer working in an engineering office, parking layout was one of those things that was kind of painful, mainly because if you were doing a traditional approach using CAD-based tools, you were doing a lot of offsetting, a lot of trimming. And in order to figure out how many parking stalls you often had to rely on counting and having somebody double check your work. So something like the parking layout tools within vehicle tracking is extremely useful for going through and making sure that you can do something like a parking layout very easily. So again, I'm going to go ahead and just start off with a standard. I'm going to go ahead and just load one in by going to File, Open, and I'm going to go ahead and just browse to my project location. And I believe I have a standard set there. And again, there's a lot of built-in standards, but you can create your own depending on the jurisdiction, agency, or area that you're designing your project for. Once I've set my standard, what I'll do just quickly show you is that if I were to edit a copy, right, you have a lot of different ways you can control the dimensions, the types of class of vehicles that service those parking spots, the angles that are associated with how somebody may park in those, et cetera, et cetera. I do have my parking standards set up, so I'm just going to start drafting some rows. And what I'm going to do is I'm going to start with just drawing bays along the left side here. And the nice thing is all I need to do is snap to this geometry, and you're going to see that it's going to start laying this information out. Now I'll just quickly go through this just to give you a very concrete example. And then last but not least, once that is all done, right, I'm going to go ahead and fix these by doing that. Doesn't get really any easier than this, right? I can do the same over here along this arc by just dropping in a new row. And this time it's going to be on my right-hand side. And I'll go and I'll just do something like that and drop that arc in there. All right. Now, if this was the handicap accessible area of parking, what I could do is I could change some of these parking stalls to accommodate a predefined handicap accessible spot, right? So you can see here that I'm going through and making these all handicap accessible, and it very easily was able to change those based on the standard that I had set up. If I need to get a quick count on what kind of information I have in for parking, I can go to my report, and you can see here I can have a quick count. I have 100 stalls that are standard, 100 or 6 that are handicap accessible, and I can see the percentage difference between them. I can also export this to a CSV file for manipulation within something like Microsoft Excel. All right. Last but not least, I'll just show you another quick example of, if I can close this up and give you another quick example of how you might do this in a different setup. So I'm going to go ahead and just show you how you would add a vehicle access path. So again, I'm going to use the same standard, and I'm going to go ahead and just draw a quick, let's say I want to go along the right-hand side. And let me close that up, and let's start dropping in some information. All right, let's fix that like by doing so. And I'm going to add another row down here. And I could have added both directions if I wanted to off the get-go, but what I'll do is just something like this. Now, obviously, there's a need to have egress and ingress from this location. So what I can do is I can tell vehicle tracking that I'd like to add a access road. And what I'm going to do is I'm going to start with my access road there. And I'm going to go ahead and just say, using my extension, just go through that location and make it accessible for a type B two-way along the center line, right? And as soon as I do that, it cleans up that area, and probably should look at my standard a bit closer, but need to jut those out a bit more. You can see it actually split those areas up and made it easy for me to now adjust this parking layout. One thing you can also note is that if I pick a passenger vehicle, it helps if I spell passenger right. Right, I'm going to go to my AASHTO standard and select the passenger vehicle. When you're using vehicle tracking vehicles within the parking layout, it'll automatically snap to those parking structures that you have. So if I start with a vehicle here, I can show how it may back up. And then if I want to turn on the spot, I can turn on the spot and continue driving along my merry way. Again, I'm all over the road here. So what happens when you have a New York City kid trying to drive within a parking lot. And I'm going to just line it up with this line right there. And of course, I'm all over the place, but you get the idea. All right. Voila. All right, perfect. So with the 3 minutes I have left, I just want to touch very quickly on the last product, 3ds Max Interactive. Again, part of your AEC collection. What is it used for? Well, you can certainly import geometry from a number of external sources. And then you can create, based on some of the built-in templates, some navigation meshes to your objects to add some realism to your scene. Now, I'm going to give you a very brief example, A, because I don't have time, and B, because it's a little bit more involved than what could be covered in just a sort of walking through the products within the AEC collection. But what I'm going to do is fire up something I already had included. I fired up a 3ds Max Interactive using one of the vehicle templates, where if I were to run the test you can see that I can drive through the space that's designated, right? And I can see through the audience view, it's not necessarily very indicative of how smooth the animation is because of the screen trying to catch up. But what happens if I wanted to use something that I've already created in this regard? Well, the nice thing is I can add content to the model. So I'm going to go ahead and create a site. And from there, I'm going to go ahead and bring in some geometry I already exported from my project. So if I go to my FBX folder, actually, I'm sorry, it's in my documents folder. I already exported a little bit of information. I'm just going to drag and drop that in there and accept the defaults. And what it's going to do now is it's going to process and import that information. So I'm going to let that do its thing. And then maybe I'll jump over to Roger real quick and see if there's any questions about any of the number of things we've touched upon.
Hi, Steve.
Roger, are you there?
Sorry about that.
Hey, there you are.
Yeah, absolutely.
No worries.
No, absolutely. There's an enormous amount of great information being displayed. Andre wants to know if we're going to be able to program this self-driving trucks so we can get narrower roads in the future.
I mean, I wouldn't imagine that. You probably have a lot tighter vehicle control using a computer-aided, or I should say an AI-aided application rather than a human. But all the information regarding the minimum turning radii for these vehicles based on their design is available and built in directly through vehicle tracking. And there's no reason you can't create your own vehicles. There's a whole section dedicated to creating your own vehicles within the application as well. So in my vehicle library explorer, I can fire that up and I can go ahead and create brand new libraries and new vehicles and so on and so forth to create my own vehicle based on AI-driven vehicles or not.